In today's lesson, we are going to build a little bit off of the collecting like terms that we did in a previous lesson and look at a new concept called distribution. So in a warm-up, over the weekend I took my kids and their friends to McDonald's and I ordered 2 of the hamburger Happy Meals and 3 of the chicken nugget meals. What food do we have on our table? So in total, what food do we have? Right, so we have our hamburger Happy Meal over here. We can see what's in it. And same with the chicken nugget meals. Right? So if you think about it, okay, well, I have 2 hamburger Happy Meals. So that means there's 2 hamburgers. There's 2 French fries. And there's 2 pops. If I look at the second Happy Meal, or the 3 chicken nuggets ones, I have 3 chicken nuggets, 3 pops, and 3 French fries. So those are all the items that I have. And then if I want to combine them, 2 hamburgers, plus we talked about collecting like terms. So 2 French fries plus 3 French fries is 5 French fries. Plus, you could say go back up and do the 3 chicken nuggets. Plus, we have 3 pops and 2 pops. So 5 pops in total. So overall on the table, I should have 2 hamburgers, 5 French fries, 3 chicken nuggets, and 5 pops. So this is an example of kind of distribution. But let's see if we can represent this expression or this idea in a different way than we've done. And we can represent it differently because we can represent it as this. I had 2 French fry or 2 hamburger Happy Meals plus 3 hamburger Happy Meals. So what would this look like? Well, 2 hamburger Happy Meals. Well, what's included in a Happy Meal? I have French fries plus a hamburger plus a pop. If I look at the next one, I have 3 chicken nugget ones. So I have 3, there's a chicken nugget in there, or chicken nuggets, there's pop, and then there's French fries. So this could be the same thing. We know that it becomes 2F plus 2H plus 2P plus 3C plus 3P plus 3F. We know that's the case because we've done that on the previous one. But how did we get here? What did we do? Right? Because we had 2 times something in brackets. So how do we multiply when we have a number outside a bracket that has multiple items on the inside? And if you kind of compare how we got here, hopefully you'll see that in order to get here, this 2 had to be multiplied to the number of French fries, to the number of hamburgers, and to the number of pops. The 3 was multiplied to the number of chicken nuggets, the number of pops, and the number of French fries. So when we have a number on the outside or outside brackets, that's basically saying that that number gets multiplied to everything on the inside individually. And that's what we call the distributive property. So that's when we take something on the outside and we multiply it through everything on the inside. And then again, we know that we can add these all up. We can get our 2 hamburgers plus 3 chicken nuggets plus 5 French fries plus 5 pops. So again, we can combine our like terms similar to what we've done in a previous lesson. Let's show where they all simplified to. So it's just basically an added step depending on what our expression gives us. So let's look at a couple examples of the distributive property. I want to expand, which basically is just another word for multiply, and then simplify. So I'm going to multiply things out and I'm going to use collecting like terms to simplify it. So in this case here, 2 times x plus 5. that's how this would be worded as. It's 2 multiplied by x plus 5, or you could say x plus 5 times 2. This 2, because it's on the outside of the bracket, gets multiplied to the x and to the 5. So if I have 2 times x, that's basically saying I have 2x, and then 2 times positive 5 gives me 10. Can I simplify this further? Can I collect these like terms, or are these like terms that I can collect? Looking at them, we should recognize that no, they're not. 2x, there's an x there, there's no variable on the 10, so that's as far as I can go. Moving on to b, b's the same thing. I have negative 4 outside a bracket of 3x plus 1. So this means negative 4 times, in brackets, 3x plus 1. So this negative 4 has to get multiplied to the 3x and to the 1. Again, take the sign in front. It's not a positive 4 that you're multiplying through. You have to multiply through the negative as well, because the negative is included. So negative 3, actually I'll write this one out. Sorry, negative 4 times 3x plus negative 4 times 1. So I've multiplied it through. I'm showing basically all the steps. This becomes negative 12x, because when you multiply, you're multiplying the two numbers. So negative 12x minus 4. Again, I can't simplify this any further because there are no like terms. This one over here, I'm just going to move this down just so I can show that in between step of 2 times x and then plus 2 times 5. Just so again you can see how we got to our final answer, even though you see what we're doing hopefully with the arrows. Let's look at some more complicated ones. So here I have 2 times 3y minus 1 plus 3 times y plus 4. So you can have multiple distributions within one expression. The key thing is, though, the number is only going to be distributed to the bracket it's attached to. So that 2 does not get multiplied to anything outside of this bracket. This 3 gets multiplied only to the y and the 4. So in this case, I end up with 2 times 3y plus 2 times negative 1 plus 3 times y plus 3 times 4. Again, you don't need to show that step if you're comfortable doing the multiplication as you draw your arrows. So I'm just again showing the steps. 2 times 3y gives me 6y, plus 2 times negative 1 is negative 2, plus 3 times y, which is 3y, and plus 3 times 4, which is plus 12. Now what I'm going to do, I can simplify this because there are like terms. I have the 6y and the 3y, and I have the negative 2 and the positive 12. So I'm going to combine those like terms. 6y plus 3y gives me 9y, and negative 2 plus 12 gives me positive 10. I can't simplify this part any further because, again, I don't have like terms, so I'm done. I've expanded it, I've multiplied, and then I've simplified it by collecting like terms. For D, again, same idea. 4 times the 3x times the plus 1. So 4 times 3x and 4 times positive 1. Let me write those down now. The next part is a little bit different. I have a minus here. We can assume, though, that there's a negative 1 in front. There's an invisible 1 there. So that invisible negative 1 is going to get multiplied through to the rest of them. So I'm going to add negative 1 times 5x and then plus negative 1 times negative 2. When I go through and I simplify this, 12x plus 4 minus 5x plus 2. And you'll see all that negative really does is just change the signs in the second bracket. Instead of it being a positive 5x, it's now negative, and instead of it being a negative 2, it's a positive 2. So that's really all the minus or the negative 1 does. It just changes the sign. Next, we're going to go through and simplify. Let's go through and find our like terms. So I have a negative 12x, and a positive 12x, and a negative 5x, a positive 4, and a positive 2. So when I simplify this, 12x minus 5x, or 12 minus 5, is 7x. 4 plus 2 is 6. So that's the expanded and simplified form. In the next examples, we're looking at the same thing, except the variable or the term in front of the bracket is now a letter or has a variable attached to it. So that is going to be a little bit different, but the main concept is going to be the same. X times x minus 5, so this x is going to get multiplied through to both parts. So that means x times x, and then plus x times negative 5. I'm going to go through and just multiply this. X times x becomes x squared. Or you could think of multiplying powers. A power times a power. 1 plus 1 is 2. Plus x times negative 5 becomes negative 5x. I can't add anything here. These are not like terms. Even though they're both x, they are different. X squared is different from x, so please keep that in mind. For b, again, same idea. Negative 2x is going to get multiplied through the first bracket, and then x is going to get multiplied through to the second bracket. When you're dealing with just variables, or when you're dealing with variables, again, the numbers you just multiply straightforward. So if I look at the first one, negative 2 times 1x. When I multiply the numbers, negative 2 times 1 is negative 2. Or actually, let me write out the fully expanded form so we can see what we're multiplying. So negative 2x times x plus negative 2x times negative 2. For the first set, for the second bracket, x times x squared plus x times 3x plus x times negative 1. So going back to what I meant about multiplying the numbers and the variables, if I look at negative 2x times x, you could say there's an invisible 1 with that x. So negative 2 times 1 is negative 2. X times x is x squared. For the second one, negative 2x times negative 2. Multiply the numbers. So negative 2 times negative 2 is positive 4. And the x is just carried over. X times x squared. So again, you could think of this as our power rules. X to the power of 1 times x to the power of 2. Add your exponents. 1 plus 2 is 3. Or you could say, well, I have 3 x's all multiplied together. X cubed. X times 3x. There's no numbers to multiply, or you could say there's a 1, an invisible 1. So 3 times 1 is 3. X times x is x squared. And then lastly, x times negative 1 is negative 1x. What I'm going to do now is, again, go through and look for my like terms. I have terms that have an x squared. I have terms that just have an x. And I have one term that only has x cubed. So these are all different. Even though they're all x's, they're all different versions of x or forms of x. I'm going to put the x cubed first. General rule of thumb, the higher the exponent, it should be at the front. So x cubed, my x squareds are next, so minus 2x squared plus 3x squared. Here when I'm collecting like terms, when I'm adding and subtracting, I'm only dealing with the numbers in front. The variables are just there indicating what type of item it is, you could say. So negative 2x squared plus 3x squared is plus 1x squared. And then 4x minus 1x is plus 3x. So that is my simplified form. Lastly, for C, again, it's going to be the same idea that we've been doing, except the x squared is going to be multiplied through. So just different numbers or different terms that we're multiplying through. And in the second one, it's the whole thing of minus 4x that gets multiplied through. So again, keep that in mind. It's the entire thing that gets multiplied through. So breaking it down, x squared times 3x is the first one, plus x squared times 1 plus negative 4x times 2x plus negative 4x times negative 5. And now I can go through and simplify each multiplication. Again, you may already be able to do that as you indicate what you're multiplying. You don't have to show this step. It is just a little bit easier to keep track of what you have to do, and it makes sure or ensures that you're not missing anything. So x squared times 3x, multiply the numbers. 1 times 3 is 3. X squared times x is x cubed. Plus x squared times 1 is just x squared. Negative 4x times 2x. So here I'm going to multiply my two numbers. Negative 4 times 2 is negative 8. X times x is x squared. And in the last multiplication, I'm just going to multiply my numbers. So negative 4 times negative 5 is positive 20. And the x doesn't have anything to multiply with, so it stays. Once I've expanded, I'm going to go through and try to find my like terms. Do I have anything with x cubed? I only have the one term, so that's all I'll leave it at. I have an x squared, a minus x squared, so those two are like terms. And then finally, I just have a plus 20x. So there's really only two things that I will be combining here. The 3x cubed just stays the same. My x squared minus 8x squared, so you could say 1x squared, or 1 of something minus 8 of something, gives me negative 7x squared. And then the plus 20x is just there at the end. Again, we're trying to keep it in sequential order, highest exponent first or highest power. So again, you can just make yourself a note of that. Highest to lowest exponent. Again, that's just a general rule of thumb. It's not wrong if it's out of order, because it still is the same thing. But general rule of thumb is you do want to have the highest exponent down to the lowest exponent. So x cubed, so 3, 2, and then 1. Looking at a perimeter expression or example. So we've done examples like this already, where we've had to collect like terms by coming up with an expression for the perimeter. Now, you may come into situations where the perimeter is not a single term or multiple terms, but we have actually a distribution. So again, we start off the same way. Perimeter is just going to equal all the sides added up. So side 1 plus side 2 plus side 3 plus side 4. Side 1, we could say, is 4 times x minus 2, plus the next side, which is 8 times x plus 2, plus 4x, plus 7x minus 8. One thing to keep in mind, because it's addition, I don't need to really worry about putting brackets around it, because nothing's really going to change. If it was subtraction, I would have to put brackets around it. before I can simplify this, I need to get rid of these brackets. So I need to use the distributive property. I need to multiply the 4 into the one bracket and the 8 into the other bracket. So 4 times x, again, I'm going to just make this a little bit longer by showing the full steps. 4 times x plus 4 times negative 2 plus 8 times x plus 8 times 2. And then everything else can just be added on or stays the same at the end because we don't have anything to multiply through. 4 times x is 4x. 4 times negative 2 is negative 8. 8 times x is 8x. 8 times 2 is 16. And again, the 4x plus the 7x minus 8 all gets carried over. Now that I've distributed everything, I've expanded everything, now I can work on simplifying. So I'm going to go through and find all my like terms. So 4x, 8x, 4x, and 7x. They are all terms that have x's. The only other terms, the minus 8, the plus 16, and the minus 8, those are all like terms because they don't have any variables. So I can collect my like terms. So 4x plus 7x is 15x. And then minus 8 plus 16 minus 8 is 0. So I don't even need to add anything else. I could say plus 0, but again, that doesn't really change anything. So I can leave it at 15x. In the next example, now we're going to be looking at coming up with a simplified expression for the area of the following. So not the perimeter anymore. So now we're dealing with area. And again, remember, area for a rectangle is area equals length times width. So in this case, we could argue that this is my length and this is my width, or we could reverse it. It doesn't really matter, and it doesn't change what we have to do. So in this case, area equals length times width. So it's going to be 7 times 3x minus 1. This is a straightforward distribution question like we've done previously. This 7 needs to multiply to everything inside the brackets. So 7 times 3x plus 7 times negative 1. Again, you don't need to show this step. I'm just kind of showing how we get there. We end up with 21x minus 7. There are no like terms, so I don't need to simplify anything further. So I am done. Again, another area question. Again, fairly straightforward. Same thing that we just did in the last one. Length times width. We say 2x times 5x minus 2. Right, now we do have to include the brackets because we want to make sure that the entire thing, 5x minus 2, is represented as one variable. So that's why we include the brackets. If we didn't, then that would mean that there would technically be, the formula would be length times width minus 2 or plus something. We want to make sure that we're showing that this 5x minus 2 represents the w. Again, we have to use the distributive property. That 2x needs to multiply through to everything inside that bracket. So 2x times 5x plus 2x times negative 2. 2x times 5x, multiply your numbers. So 2 times 5 is 10, x times x is x squared. Positive 2x times negative 2, multiply your numbers, you get negative 4. The x doesn't have anything to multiply with, so it's just negative 4x. The final example, determine a simplified expression for the area of the following shape. So this is kind of combining the composite shapes that we've looked at before with what we will find out is the distributive property, as well as collecting like terms. So we need to divide this shape up into shapes that we are familiar with. Right? Depending on how you do it, you could draw a line down here, or you could draw a line across here. Regardless of which way you do it, you should still get the same answer. The one thing we do need, though, is we need to figure out what these two options are, what those two side lengths are. What's nice is that these double lines tell us that they're the same length. So that means that 6x is basically divided up into 2, which would mean 3x, because 3x plus 3x is 6x. So we can now replace these with 3x. And now we have our two areas. We have our area 1 and our area 2. So for area 1, again, we're only dealing with rectangles here, so length times width. So here we have 3x times 4x plus 7. You can use your distributive property, multiply the 3x through. So 3x times 4x plus 3x times 7. Again, when we have numbers and variables or numbers and letters, multiply your numbers. 3 times 4 is 12. X times x is x squared. And then 3x times 7 is 21x. The second shape, again, area equals length times width. Doesn't really matter. We can say 3x is the length times x plus 2. Again, we're putting it in brackets because x plus 2 represents the entire variable. We need to take that 3x and multiply it throughout the bracket. So we're left with 3x times x plus 3x times 2. This gives us 3x squared plus 6x. Lastly, because we want the total area, we need to add up our two areas together. So 12x squared plus 21x plus 3x squared plus 6x. So again, adding up all those terms. We can simplify this because we can find like terms. So we have our x squareds. And we have our terms with just the x's. So when I go through and I simplify this, 12x squared plus 3x squared is 15x squared. When we're collecting like terms, remember, do not touch the variables. Leave them. They're telling us what item we're dealing with and how many. So we're just adding the numbers. So 12 plus 3 is 15 x squared. And then for the x's, 21 plus 6 is 27x. So that is our total area for this shape. 15x squared plus 27x. Again, that's as far as we can go. We can't add those together. They're not like terms. And we don't know what x equals until we get to question B. Because question B is telling us determine the area when x equals 3. So we know the area is equal to 15x squared plus 27x. We are also told now that x equals 3 in this scenario. So looking at this, I can go in and I can replace the x, or all the x's, with 3. So 15, instead of x squared, it's now going to be 3 squared. So keep in mind, you're only replacing the letter. You're not getting rid of any exponents or anything like that, just the letter. So 15 times 3x, or times 3 squared, plus 27 times 3. Now I can just go through and calculate to get a final area. So 15 times 3 squared, or 9, is 135, plus 27 times 3 is 81. So 135 plus 81 is 216. And we don't have any units, So if you wanted to, you could say units squared because it's area, or you could just leave it at 216. So what we've looked at today is using what we call the distributive property. So this is when we are dealing with terms or numbers multiplying a bracket that has multiple terms on the inside. And again, we should recognize that what we do, you could call it the rainbow method or distributive property. The term on the outside is multiplying everything inside the bracket it's attached to. And then from there, once you multiply or expand, you can collect like terms and simplify your expression. So basically this is kind of a continuation of our collecting like terms lesson.